All right, so welcome to lesson 011, and here we're going to talk about uh, the impact of the ground dust explosion, the additional dust, and here we like to give the fluid emitter to our existing particles. We have already created the rig setup of our particles in the previous lessons, so here are the particles for that, and now it's time to assign fluids to them. So beginning with the creation process of our emitter, we'll like to create the emitter, and first of all we'll start balancing them out. This reaction is really going to be important because computational is very expensive. Also, you're going to end up, if you're going to use 150 as the base resolutions, it might could be possible that you're going to end up with the resolution of X somewhere around 650 or maybe 700, which is quite a high one. So I'm very careful in using the size and the resolution for this particular reactions. So for the y-axis, we like to give it 5 in the beginning because this reaction won't going to pick up too large in the y positive zones. The rest of the settings are pretty good. X and Z are quite okay. Let's say we could give it to 12 for the X, and let's say 12, or I think so maybe 10 is fine for the Z only. Now it's time to give the boundaries. There is no boundaries for the X. There is negative Y boundary for the boundary Y, and for the Z we'll like to go with the negative Z since we're not going to utilize the backside of our fluid containers. Okay, so in this reaction, the density, velocity, and the turbulence, three are the key important attributes for this. We're not going to utilize the temperature and the fuel at all. So we'll go to the outliner, selecting particles, selecting fluids, for the fluids first, particles then, and we're going to go for the emit from the object with the Omni type and apply and close. Okay. And first of all, I like to give some very important settings to the fluid emitters, which are really very important. We like to crank up the rate to 250 because I can't use the max distance one, which would be severely a very high value in this case. So let's kick that down to zero point 0.5. The density I like to go with the 3, would be a little bit high density. Of course, the ground dust is also, uh, pretty much high. No need for the heat and no need for the fuel. And obviously, we're going to utilize the motion streak since we have already discussed that the fast moving fluids we're going to produce some stamp size problems. So to avoid that, the motion streaks are the perfect solutions. We are enabling the jitters, not a problem. The turbulency we're going to be 15. Turbulence speed will going to be, let's say, 0.55, and the frequency will be a little slow, 0.2 and 0.1. We're going to use the detailed turbulence to on. And the most important attribute for the emission of the fluid is here. The emission speed attributes like to go for the replace with the inherent velocity to 0.25. The reason why I'm using this because the particles will gonna drive the fluid because of the inherent velocity. I'm not gonna give it to the full value because that may gonna take the fluid along with them, which is not the case. The moment the particle will gonna get die, the fluid will give a little push. Okay, that's the utilization of the replace and the inherent velocity. So with that, we have already provided with the fluids. Let me just gonna increase the resolution to 60 so that it will be easier for me to observe, and we'll get dip down the boundary dot, the bounding box. Okay, and let's just do one thing quickly. We're gonna start setting the values of the damp to 0 to 0. The high detail solver going to be all grids. The subsets to be the 3. Solver quality will going to be 45. And here in this case, we're not going to utilize the simulation rate scale. We don't want to change that up. Let's say the 1 is a default value because the particles are moving fast, so the speed of the fluids will going to depend upon them for the initial frames. We're going to utilize the emittance substeps, otherwise there's no way in talking about the substeps. The auto resize should be given to the auto resize, but this case we're not going to utilize the resize to the emitter. And let's say we're going to give 4 to the auto resize margin, 4 to maybe 5, because the particles are very high speed moving particles, so We just cannot, afford to give some lesser values of the auto resize margin. So I guess 4 or 5 are going to work pretty much fine. And of course, moving to the density sections, the buoyancy, we like to give it to -3. Reason why? Because the dust has to get settled upon the ground. There is no way to use the upward values to give the rise to the fluids, otherwise they'll convert themselves to the smoke. The dissipation, we like to go with 0.5. We want the dust to settle and, get dissolved away. Not fast, but at a little pace of the time. And leaving all the other attributes, the noise is going to be 0.050 or maybe 25. We're going to use little noise. And the gradient force will going to be 20, maybe 25. Like to go with the velocity of the 6 or let's say 5, we're going to go work. And the most important attribute here is the turbulence. So I would like to key that up. First of all, I need to disable the evaluation. And for the turbulence, let's say we'll begin with 15. Set key. The frequency will go to 0.1. The speed also will go to 0.15, I guess. And let's say at frame 15, or let's say at frame 15, we like to come back to 0.125. Okay, set them up. Now it's time to enable the fluids. And before I just play, I would like to also little bit tweak and tune the opacity graph, because it would be difficult for me to visualize the fluids, and also would like to switch on the self shadow. The rest is pretty fine. We're gonna give some brown color of the dust to that, and 0.3 is quite good. Okay, we're gonna come later on these values. Just for some, basic setup, I think 0.5 and 0.35, we're gonna go proper. We're gonna properly work, no issues. We leave the transparency in that way, the drop off need to be off. And now it's time to play. So here you can see that the fluids are, coming all across the surface, not the surface, but from the particles. And the only biggest issue which I'm facing here is the visibility of the fluid in the initial phase. So the trick what I'm gonna use here is that to key down the transparency. Well, the reason why I just want to go with that, because if I'm gonna dip down the transparency, you're gonna notice that the fluid won't going to come up the way they are coming just right now. Okay, just do one thing, just for our demonstration purpose. Let me just gonna, uh, give the dusty impact, and we also do one thing. I'm just gonna switch off or hide these particles control edge. All right. So with that, if the transparency is pretty low, you may could see that there won't going to be impact of, you could say, the blobbiness or that kind of the disturbances in the pattern of the fluids. All right. So we do one thing, we're going to take a pause over here. We're going to join the next lesson, and then I'll like to further go ahead with the properties of the fluid containers. All right. So we're going to take a pause.